Right. So this is one of the questions that you sent me with incomplete attempt.
Yeah.
Okay. Let's see how we can deal with this. Okay. So let's read the question first. Sketch the curves y equals to sine x, y equals cos x for 0 less than equal x less than equals pi over 2. Then after that, you want to calculate the area of the region enclosed. So where is that region? Can you show it for me? Where is the region?
The curves and the x-axis.
Yeah, for part A is the curves and the x-axis. Okay, that's not what they meant. That's not what they meant.
That's not what they mean. They mean here.
Yes.
Okay.
So it's like a region that is bounded by the sine x, the cosine x, and the x-axis, right? This one, and this one.
Okay.
So that's for part A. So I think maybe you can label them. Is it pi over 4?
Wait.
How do you know?
Okay.
By drawing symmetry?
No. Wait. Oh, I was gonna sub y equal sine x into y equal cosine x.
That's correct. Yes.
But you just get sine x equal to cos x.
Yeah. How do you solve this?
Tangent x equal 1.
Yep. Assuming that cosine x is not 0, then you can divide. Then how? Good. And then you realize that, oh, what a coincidence it is.
Pi over 4.
Yes, it is pi over 4. Okay, it's a coincidence. Please do not assume.
It's not.
So what we want to do is to always first start off. Maybe I should give you a recipe to follow to find this. Step 1, find intersections, intersections. But more specifically, you want the x coordinates of those points. Okay, can I just write down POI?
Yeah.
POI, point of intersections. Yeah, a bit shorter. X coordinate of those point of intersections. In this case, only one. So let's mark a cross here. Then how would you do that? For step 1, you will have to equate 1 to 2. Equate. So in this case, 1 equals to 2. Then from there, y equals y. So whatever you just did, right? Let me just quickly copy it down. Okay, divide by cosine x. End up with tangent x equals to 1, x equals tangent inverse of 1, which happens to be pi over 4. Okay, good. So you then look at the point of intersection. Now, this is a point where you change the curve, right? Imagine you're on an MRT. Let's say you're on the east-west line, then you're at Jurong East. Then you have to change to a different MRT, change to a different track, right? So those are the points where point of intersection. So you want to drop a vertical line down when you are integrating with respect to x. Okay, then you realize, you can split into 2 separate regions. Here, you can find the area. There, you can find the area. Then my recommendation is, actually write this down, split with vertical lines. And number 3 is label each region. So maybe we can do it slowly. Step 2 is already done. Now let's just say this is A1 and that's A2. Okay, so A1 is on the left here. A2 is on the right. Can you see?
Okay. Wait, no.
So you can think of it like this. There's a upper function here. I'm highlighting in green. And then there's a lower function there, which happens, the lower function happens to be x-axis, y equals 0. So it's sine x minus 0. right? But it's just sine x. Oh. Very good. Yes, exactly. So let's just calculate it. A1 equals integral 0 to, sorry, I forgot to label, pi over 4. Pi over 4, then what's the function? Sine x dx. What I was saying just now was sine x minus 0 because I want you to recall the identity. When you have an area that's trapped in between a curve and the top and the bottom, you always take the by the upper function and a lower function, you always take the integral of the upper function minus the lower function. But you integrate from the left x value to the right x value. X equals 0 to x equals pi over 4. Yeah.
Okay.
Very good. Yes. Yes. Let's continue. X equals, calculate this, negative cosine pi over 4, minus away, negative cosine of 0. Cosine pi over 4 is 1 over root 2. Sorry, did I remember it wrongly? Let me think. Yeah, it's correct. 1 over root 2. Minus away, minus becomes a plus. Cosine 0 is all. Cosine 0 is...
Cosine 0 is it 1?
Yes. Look, you already drew it over here. Cosine 0. At x equal to 0, y equal to 1. Okay, good. So how about A2? Do the same thing. So this time it's pi over 4 all the way to pi over 2, right? Yes, whatever you wrote down. Okay, let me just quickly write this down. So differentiate sine x, you get cosine x. So that's why integrate. You just work backwards. X equals lower limit pi over 4 to upper limit pi over 2. Sub in the upper sine pi over 2 minus sub in the lower sine pi over 4. So what's sine pi over 2?
Sine is a very long decimal.
No. What is maybe you just do it inside your head. What's pi over 2 in terms of degree?
1.
Huh? Pi over 2 in degrees is?
As in sine pi over 2 is 1.
Yes, correct. Yes, it's 1. Then how come you were saying decimals?
No, as in like if you do calculator.
The whole thing in the calculator.
Yeah.
No. We want exact value.
When
So how about sine pi over?
Yeah, when sine pi over 4 is like a very long decimal.
So you need to remember the trick. This one, pi over 4 is an exact angle. In terms of degrees, maybe it will help you.
Square root half.
How many degrees? Square root half. Yes, correct. Yes, square root half. But I recommend you to remember it as over 2, over 2, over 2, square root, 1, 2, 3. 30 degrees, 45 degrees, 60 degrees. This is sine theta. When theta is 30, 45, 60. Can you see the pattern?
Okay.
Of course, that's because of the 30, 60, 90 triangle and the 45, 45, 90 triangle. You remember those two?
Yeah.
Yes, okay, I don't draw again. Alternatively, because you have a calculator, how do you recover this square root 2 over 2? Sine 45 degrees, which is pi over 4 radians. Type inside, you get a bunch of decimals.
Square.
Then you square it exactly. Square it and you end up getting an exact value 1/2. Okay, the calculator is smart enough to know that the square of a square root gives the exact value 1/2. Then now, because the calculator help you to get 1/2, you reverse engineer. You actually need sine pi over 4 without the square. So you take a square root, so square root the 1/2, which is square root 1 over square root 2, which is 1 over square root 2. Multiply top and bottom by square root 2 to rationalize the denominator. You end up with square root 2 over 2. Okay, that's how you do it if you cannot remember. Anyways, square root 2 over 2. Very good. Or 1 over root 2. Actually, you know what? Because previously I already wrote down 1 over root 2. I'll follow the same pattern. I'll simplify it down to 1 over root 2. Is that okay?
Okay.
Okay, very good. And finally, therefore, A1 plus A2 will be minus 1 over root 2 plus 1 plus 1 minus 1 over root 2. Anything to cancel? No. Here it's a negative and negative. There is a positive and positive. So it's actually just 2 times of the same area. So 2 times of this plus this, right? Okay, very good. Then, okay, let me shrink this down. Put it aside. Okay, multiply in the 2. So you end up with negative 2 over root 2 plus 1. What's 2 over root 2? Maybe I rewrite as 1 minus. 2 over root 2 is?
2 over root 2 is 2 root 2 over, wait, root 2.
It's just root 2, yes. Right, because 2 over root 2 is root 2 square over root 2. Right, then you can cancel off one copy of root 2. You're just left with a single root 2. Okay, good. That is the area, 1 minus root. Okay? Okay, not enough. We still got part 2. Still got part 2 now. Moving on. Part B. The curve, you want the area of the region enclosed by the curves and the y-axis. This time I'll use blue color. So y-axis is here, curve and the other curve. So where is the region enclosed by those 3 curves? And straight lines. Y-axis.
Yeah.
This curve and this curve. Which region? Can you shade it for me? Very good. So let's just shade it in like this now. Can you think of a faster way to answer this question? That a lazier way.
Wait.
Okay. Actually, you know what? Let's just discuss any way will work. Well, let's just discuss it.
Wait, what do you mean by a faster way?
Actually, there is no. I can see 2 ways to solve this. Both are also equally same speed. No, not much faster. Sorry. What do you suggest? Oh, draw a horizontal line. Can.
No, but the thing is, like, it's the square root half.
Nothing wrong with our square root. Nothing wrong with our square root. Why? What's wrong? Okay.
Okay. You tell me if this makes sense. Oh wait, no, I'm supposed to do this. All right. P1, P2.
Okay. I label for you.
Okay. You tell me if this makes sense.
Go ahead.
P1. Okay, wait. This.
Okay.
No, because it's not even
What
this.
do you have? What do you need as a subject if you want to try integrating with respect to y?
Oh, if I need to make, so it's like this. Can it be like this?
Correct. Yes, can.
Then the one below is like
cosine inverse y. Yes, good.
Okay.
And continue your B2. You are on the right track. B2.
Does it make sense if it's like
yeah. The 0 and the 1 over root 2 is y equals so they are horizontal line. This is dy. Correct. Yes. And then.
But then how do you integrate inverse trio?
Very good. Write it down. Okay, very good. It means I teach you correctly already. Integrating with respect to the y requires you to make x a subject. Then you can integrate from the lower horizontal line to the upper horizontal line. Right? So your setup for B2 and B1 is perfectly fine. It's just that in the syllabus, I haven't teach you how to integrate sine inverse and integrate cosine inverse. So you cannot use this method. because I haven't taught you. Okay, but in the future, if you're ever using a computer to calculate the numerical answer, this is perfectly fine. Okay, just to let you know. Very good, you got the concept right. But because I haven't teach you how to integrate sine inverse and cosine inverse, you cannot solve it. I think it's good to write down. Let's just write it down. This is simply because it's not wrong. It's just because it's outside the syllabus. Okay, let me just write this down. This is part B. Let me copy the diagram. Okay, we call this method number 1. So you found B. You decided to make X the subject first for each of the functions. Then for B2, you realize that it's underneath the X equals sine inverse and this X equals 0. So that means that you have to integrate from here to here, which is y equals 0 to y equals 1 over root 2, right? So that means that you label y equals 0, y equals 1 over root 2. Maybe I should label y equals 0. This is y equals 1 over root 2. Okay, then you integrate across the function sine inverse of y dy. Likewise for the b1, but now you just go from 1 over root 2 to y equals to 1. Maybe I'll just draw in the y equals to 1 first. Yeah, then you just integrate from y equals 1 over root 2 to y equals to 1. And then you have an integrand being, sorry, the other curve, right? Because this region B1 is, the right side of the B1 is this cosine inverse y. The left side is the x equals to 0. So you can think of it as cosine inverse y minus OA 0 dy. Upper curve, maybe I highlight it like this. Upper curve is cosine inverse y, lower curve is 0. Okay. This is okay, perfectly fine, but not in syllables. Cannot integrate yet. Okay, good. Now let's move on to method 2. A method that actually can work. Let's think of a method that can actually work. We found A1 and A2 already, right? Remember? A1 plus A2 is equals to, what was it? 1 minus root 2. Okay, the answer from before. Right? Yes? Mic test, can you hear me? Oh, I cannot hear you.
Yeah.
Don't tell me I'm talking to okay, very good. Yes, need to check. Okay, good. Then can you remember in primary school when you want to find a shaded region, and then you got this, or maybe if I left this as unshaded,
So
and these two parts are already
find this whole thing.
Yes, exactly. You
But
find the
then-
total.
Yeah.
Can you find the total area? Please don't tell me it's a quadrant and you just 1/4 pi r square. No, not that simple. So how? Find the total first, right? In other words,
Wait, why I cannot find it by itself?
sorry, what do you mean by itself?
Like, why cannot make it like the upper minus lower thing, then cosine X?
Yes,
Oh.
that is the method 3 I was talking about. Okay, but never mind. Since you talk about it, okay, that works as well. B1 plus B2, you can, let me just redraw the diagram like this. Like this. Like this. What you realize is that I can erase away the parts that I don't want. Okay, just erase away. Okay, and then I'm just left with this region over here. You realize that there's a top curve, which is, what color did I use just now for top and bottom? Green and blue. Okay, I'll be consistent. Green at the top, blue at the bottom. Right? So it's just cosine x minus sine x. Yes. piece 0 to pi over 4. Okay, very good. So in this case, be careful. No, integrate sin x. Do you get what?
Oh. Integrate sin x.
Yes, there'll be a double negative. Always double check by differentiating. Differentiate sin x, you get cosine x. Differentiate positive cosine x, then you get negative sin x in the integrand. Okay. So this is equal to, okay, let me just copy down your working. The top function, the green one, cosine x, minus away the bottom one, sin x dx. What was it again? Sin x plus cosine x. I'll just highlight the plus. Then x goes from 0 to pi over 4. Now we just sub in. So what's sine pi over 4 and cosine pi over 4 again?
Sine pi over 4 is square root half.
Okay. Square root half. Can. Square root half.
Then the other one is also square root half.
Very good. Minus, what's sine 0?
Sine 0 is 0. Cosine 0 is 1.
So then if you forget the brackets and you write down plus 1 like this, is that okay?
No, cos is minus 1.
Very good. The brackets means that the minus must multiply in, and then you will end up with a minus 1, not plus 1. Okay, the brackets are important now. So keep the brackets. Okay, so over here, square root 1 over 2, it will be a lot neater if you rewrite it as 1 over root 2 or root 2 over 2. Here, I will choose root 2 over 2. Why? Because it's simpler for me. Simpler for me. I'm more used to it. Root 2 over 2 plus root 2 over 2. At this stage, it's 1 apple plus 1 apple. How many apples? Oh, it's blocking. 1 apple plus 1 apple. 2 apples, right? 2 apples. Okay, this is the apple. Okay, draw an apple. So if you have 2 copies of apples, it means 2
Just
times root over 2. And the 2's cancel away. I'll just drop the equal sign to save some time. Then equals to root 2 minus 1. Okay. Can? Very good. Let's try method 3. What I was trying to suggest just now. But method 2 is also pretty fast. In fact, it's actually very fast. You could think of it as I want to find the total area first, which is really just A1 plus A2 plus B1 plus B2. And how would you do it? What function? Yes. Exactly, that's it. Okay, let's just quickly calculate that.
Sine pi over 2 minus 0.
Exactly. Sine of 0 happens to be 0. Sine pi over 2 is
square root half.
Wait,
no.
Look at the graph. Pi over 2 is
0. I mean 1. It's just
1. Yes. So 1 minus 0 is 1.
1 minus 1 minus square root 2.
Yeah. So, wow, this one very messy. Let me move my working around, make it neater. This guy, I'll shift it a bit more to the left. This guy is just a recall of part A's answer. Method 3 is this one. Yeah, you just have to subtract, exactly, that's it. So therefore, finally, B1 plus B2 is actually just A1 plus A2 plus B1 plus B2, but I want to get rid of A1 and A2. I purposely wrote it like this because this part here is the same as that part there, which means that it's really just equals to 1. So that means that we end up with 1, the total area. Let me get my pen first. 1 minus away the answer from part A over here. 1 minus root 2. Simplify, we get 1 minus 1 plus root 2, which is root 2. Wait, hold on. Did I do something wrongly? Answer is different. Let me see. Uh-oh, what happened? Answer is different. Let me think a bit. Cosine minus sine 0 to the power of 4. Hold on a second. One. Let me just double check my working out for A1 plus A2. Integrate sine x from 0 to pi over 4. Integrate cosine x from pi over 4 to pi over 2. Integrate cosine, okay, sine, this minus this, 1 minus this, add them. Sorry, my mistake. Over here, 2, when there's a bracket, you must multiply into both, right? So this guy should be a 2. Do you see my mistake?
Yeah.
Yeah, I forgot to multiply in the brackets. Sorry about that. Okay, good. So it should be 2 minus root 2. Okay, then over here, arrow carry forward. Just change that 1 into a 2 instead. Then over there, we also change to 2 minus root 2, which means we end up with minus 2 here. 1 minus 2 gives you a minus 1. And so it is the same as method 2. Okay?
Oh, that's how you knew it's wrong answer.
Yes. It has to be the same answer. Yes, of course. Yeah. Sorry, I didn't say that. Yep. Method 1, 2, and 3 should give me the same answer for all 3 cases with 2 minus 1. For method 1, cannot solve. Okay, not in the syllables yet. How to integrate sine inverse, cosine inverse. Need to think a bit. Okay. Anyways, moving on. This one a bit more complicated. You need to go and find the point of intersections and draw a bunch of broken lines. So I would strongly recommend you to redraw the diagram because this one not nice enough. Just focus on the quadrant 1 because that's where the action happens, right? Draw curve, maybe something like this. Extend a bit more to the bottom like that. Then you draw a tangent line. Don't have to be super accurate. You just need to make sure that it's good enough for you to get the correct answer for the integration. And you're able to see all the separate regions. Okay, so let's say they intersect here, right? This tangent line. And I can see a vertical line over where? Let me change the color first. Over here. Can you see? And over here as well. Right? Is that clear enough? Okay, maybe
Yeah.
Okay, good. So what is the region they're asking for? They are asking for, okay, maybe if I just make this a bit more slanted like this, then you can see that there is an extra region over here. Where is it? Here. Can you see? This part. What kind of triangle is it? Okay, I gave. Sorry, I should have asked what shape is it. It's a triangle, but what kind of triangle?
What kind of triangle? A right angle triangle.
Can you find area of right angle triangle? Coordinate geometry.
Yeah. Yeah.
Huh?
Wait.
You-
Wait, what
Can
do
you
you
find-
mean by that?
Can you find the area of a right angle triangle? Yeah, of course.
Yeah.
Just a triangle.
Yeah.
So how? So that means that we are already 50% done. Correct or not?
Huh?
What? Oh wait. Sorry. Maybe I should finish shading the region first. There's still another piece of the region here. Where is it? Can you shade in for me? That last piece. Very good. Okay. I just realized I forgot to draw one more vertical line. Can you see where I should draw the extra vertical line?
Is it here?
Yes, exactly. Right. Okay. So here is one strategy you can do to figure out how to find area under a curve when there's an upper function and a lower function. You can draw a number line like this. Okay, draw a number line like this. Then you label the points where there were the vertical lines, right? So maybe let me just try to make it a bit more aligned. Like this. Okay, don't draw. I think you can see until here. Okay. Okay, let me just remove the broken line. Then we label the x coordinates of all these. The x coordinates of all these vertical lines. So over here, it's really just the x coordinate of point P, right? So it's just a 1.
1.
Then followed by, what is this? It's the x-intercept of this curve. So what would you want to do? Yeah, you have to you have to set the 4 minus x squared equals to 0, which ends up being x squared equal to 4, x equals plus minus 2. Oh, so that means 1 here, 2 here, so you put a 2 here. Then the next line, where is this?
I'm not sure.
Okay, actually I realized that this probably I shouldn't have drawn it. No. I don't need this. I don't need this line. Because I can see a bigger right angle triangle here. Right? Then I can find that bigger right angle triangle directly. So I don't need this. Sorry. Wrong vertical line. Don't need. So we draw this region instead. Okay, good. Then from there, let's see. Who is above and who is below? Let's look at this region here, 1 to 2. Who is above and who is below? And above what? Above this region. The blue or the black?
The blue.
The blue, huh? Okay, maybe it would be nicer if I just label them with 1 and 2. Let's see. Have you found the equation? Oh, you already labeled like this, right? Y equals negative 2x plus 5 is equation 2. Okay, I follow your notation. As well as the curve, which is y equals minus 4 minus x squared. Was there an equation given to it? No. Okay, I'll call it equation, let's say star. Okay, then we'll draw star and 2. Where should star be in this case? In this region here.
Star will be below.
It's below, right? So we should draw a star like this. Then who is above? 2 is above. So we draw a 2 above like that. Okay. Now we move on from 2 to this region. Oh, sorry, I already chopped off this region, so I should edit my x-axis. Don't need this point anymore. I should update this value here. Oops, haven't filled in yet. What is this x value here?
5/3.
Okay, you just have to sub in 0 into this equation to solve, and you get a 5/4, 5
I
over
mean
what again?
5/2.
5/2. Okay, good. 5/2, label 5/2. Then now we look at this next region. Who is above and who is below?
Wait, what do you mean by it?
If we want to use integration, remember the formula I gave you is
Oh, okay.
integrate
Oh,
upper minus lower. Who's upper?
2 is above and then 0 below.
Very good. So it is no longer the star that's below, it is equation y equals to 0 that is below. Okay. Then from there, we can split it nicely. Integrate from 1 to 2, upper minus lower. Plus integrate from 2 to 5/2, upper minus lower. Can you see that?
Mm-hmm.
I think maybe this is a little bit more systematic, easier to follow. So let me just calculate that. Alternatively, you could just directly find the area of this right angle triangle, right? The length here will be 5/2 minus 2, which is 1/2. And this vertical length here, you need to substitute x equal to 2 into the equation. Then you can get the
Is
corresponding.
it 3/2?
Let me think. Sub in 2 minus 2 times 2 plus 5 is minus 4 plus 5, which is positive 1. This length here is 0.5.
Wait, no. Wait. Say again how you get this.
Sub in x equal to 2. So
Sub in x
what I mean
equal-
is there'll be this point here.
Yeah.
There's a corresponding y value. What is that y value here? This is the point that is along the blue line,
3/2.
which is this guy. So you sub in x equal to 2 into this guy. Maybe I should show the working. Sub
3/2.
x. Let me just quickly calculate this. Y equals minus 2 times 2 plus 5 minus 4 plus 5 is a 1. Y equal to 1, label a 1 here. So yes, the height here is a 1. The breadth here is 5/2 minus 2 is 0.5. So that means area, maybe I'll call this region, I don't know which letter hasn't been used yet. A, okay, I'll call it A. Area A equals to half times 1 times 0.5, which is 1/4. 0.2. Does that make sense?
Mm-hmm.
Okay. Can I, how do I get the 0.5 over here? It's 5/2 minus 2.
Mm.
Okay, I just write it down, 5/2 minus 2. Yep. Okay, good. So that is region A. But what's another way to find region A? It's to just do integration, right? So from where to where? X equals to?
5/2. I mean from 2 to 5/2.
2 to 5/2. You can follow this diagram, you see. This diagram. From x equal to 2 to x equal to 5/2. So from x equal to 2 to x equal to 5/2. Okay. And then who's lower? Then it's always upper minus lower, right? So who's the upper function?
Equation 2.
Equation 2, which is the blue guy, the straight line. This one. Y equals minus 2x plus 5. So minus 2x plus 5 here. Bracket. Minus away. Who's the lower function?
0.
Yeah. The horizontal line, y equals 0. So you put a 0 here. Dx. Okay. Let's see if we will also get the same answer 1/4. We should. Okay, so just integrate term by term. This gives me negative 2 x squared over 2 plus 5x. Bracket. 2, sorry, x equals 5/2. Very good. The 2 cancels away. You're left with negative 5/2 square plus 5 times 5/2. Bracket. Right? And then you subtract away the other guy, sub in x equal to 2 this time. Negative 2 square plus 5 times 2. Let's try and do it mentally. I mean, with mental sums. This becomes a 5 square 25, 2 square 4, negative sign, 5 5 25 over 2. Times 2, what do you get? You end up with 50 over 4 minus 25 over 4. 50 minus 25, that's positive 25 over 4. Then we do the next one. Minus bracket. Minus 2 squared is minus 4. 5 times 2 is 10. 10 minus 4 is 6. So minus 6. Minus 6. But 6 you can rewrite as times 4 top and bottom, 24 over 4. So 25 minus 24, you're left with 1 over 4. Ken, primary school addition. Fractions. Okay, don't need a calculator, right? But of course, if you have a calculator, you don't need to do this step. Just type the whole thing in a calculator, get the answer through. Okay. For exam purposes, just type in a calculator. But understand that you don't actually need a calculator for this. Okay, anyways, that is region A calculated in 2 different ways. Let me just bring this down. How about region, let's call this region B. Can you see? It's a bit messy now. B is the vertical line part. How do you find region B?
Integrate from 1 to 2 upper equation to lower star.
Minus 2x plus 5. And who's the lower?
The 4 minus x squared.
4 minus x squared. Okay, very good. 3x. So let's just quickly calculate this. Okay, so the only difficult part should be the setup. Drawing all these vertical lines, figuring out what are the x coordinates, who's the upper, who's the lower function, right? And taking a shortcut like realizing that this is a right-angled triangle, so you don't actually need to do integration, right? You compare the working for part A here versus the integration part, which is simpler. Clearly, this one is simpler, right? Coordinate geometry, right? So sometimes you have to be clever with that, but anyways, now is the boring part. You already know how to do it. B, let's just do it. Okay, I'll just do it for you. So negative 2x, this gives me negative x squared, right? Oh, sorry. Wrong. No. I shouldn't do that. I should demonstrate best practice. So over here, when there's a bunch of integrands, there's a bunch of terms in the integrand, you don't go and integrate straight away. Try to simplify as much as possible. Okay, simplify as much as possible. So in this case, what I mean is open up the brackets. So minus 2x plus 5. Okay, this is getting very messy. Let me just change it all to black. Minus 2x plus 5, minus 4, then plus x squared dx, right? Then you try to combine like terms. Any like terms? Yes. Plus 5 minus 4 gives you positive 1. Then I rearrange it nicely as in descending order of the powers. I get this. Right? Good. Okay, then I integrate term by term. So power 3 over 2 minus, what's this? 2 minus 2 factor out, then you integrate x, you get x squared over 2. Right? The 2 cancels away. And plus 1 integrate, you get x. Square bracket, don't need the plus c here because this is a definite integral. The c will cancel away. Then you're left with 2 cubed over 3 minus 2 square. It's just 2 square. Plus 2, bracket, minus away 1 cubed over 3 minus 1 square plus 1. Okay? Clear so far?
Yeah.
Okay, then I'll just multiply everything in. Simplify everything. 1 cubed over 3, 1/3, minus 1 plus 1, they cancel away. This is just minus 1/3. Minus 4 plus 2, that's minus 2, 8/3. So 8 minus 1 becomes 7/3 minus 2. So 7/3 is 3, 3, 1. So it's 2 wholes and 1/3 minus 2. That leaves me with 1/3. Right? Okay. Very good. Then finally, we are finally at the last step to find the total area A plus B. Total area A plus B equals 1/4 plus 1/3. Over 12, this will be times 3 times 4, so that's a 7. Right? 3 plus 4 is 7. Okay. Is this clear?
Yep.
Ken, very good. No questions? Move on. Okay, Which other one? Ah, this one, wrong. Why is it negative? Have you figured out why it's negative? This one. No? Yes?
Um,
Oh, by the way, here, this is not 4, 0, that's 0, 4. Point P. Okay, let me show you. I think it's nicer. It'll be easier if I just redraw the diagram. Give me a second to redraw it. Okay, so like this. Then you have a quadratic curve like this. Then you have a line cuts across. Okay, very good. Point Q, point P. Point P is 0, 4 here. This is origin. Q is x equal to 3. Okay. So since this is y equal to x, that means sub in x equal to y equal to x, you get y equal to 3. So sub in 3, you get 3. So over here is a 3. Over there is a 4. Okay, good. Label the equations. Okay, label the shaded region. They want this region. Let's see, what did you do here? What did you do here?
what did I do?
You integrate with respect to y, right?
I never make y the subject. I mean, I never make x the subject.
You did, you did. You see,
I
x
did.
equals to y, x equals 4y minus y squared. Then you just use the expression for x and the x. You did. The question already did it for you. So yeah. Here the interpretation is wrong. You see, when you take something minus something, you need to make sure that it is really the upper and the lower within the entire interval. Sorry if I didn't make it clear enough. Within the entire interval from, in this case, dy, right? So y equals d. Let me get my red pen. Okay, dy, so y equals 0 to y equals 4. You need to make sure that within this entire region, the upper function is y, the lower function is 4y minus y squared. Okay, so let's check whether that's true or not. By upper and lower, in this case, actually, if it's with respect to y, it will be righter and lefter. Instead of upper and lower, it's righter and lefter. What do I mean by righter and lefter? Means that this guy is positioned a bit more to the right, whereas that guy is positioned a bit more to the left. Is that true? Let's think about it. How do you interpret this? If you want to find this region, you already identified that there's a point where the curves intersect. So you should probably draw horizontal and vertical lines like this. Yes?
Okay, yeah.
Okay, good. So now you have to see righter and lefter, but you're going from where to where? From all the way from 0 to 4, right? But you have a horizontal line. So that means you should probably stop at 3 first. Go for a tea break. Have a break at 3 first. Then you continue from 3 to 4. Right? So let's think about it. Let's draw this is the y-axis. This is the y-axis. You start at 0, you have a break at 3, and then you have a break at 4. This one at the top, I'm gonna label the righter functions. Bottom, I'm gonna label the lefter functions. Okay, not very proper English, but I hope you get what I mean. Do you get what I mean by righter and lefter? Okay, functions that are a bit positioned slightly more to the right versus those that are a bit more to the left. So let's think about it. As you travel from 0 to 3, this region here, maybe it's nicer if I just split the region up, right? Right, as what we've been doing. Maybe I'll call this region A. Then I'll call the other region B. Can you see A and B?
Yeah.
Yeah, so let's take a look at region A. As you travel along the y-axis design from 0 to 3, who is the righter and who is the lefter function?
From 0 to 3.
From 0 to 3. Who is the righter function that's surrounding the shape here?
A.
Huh?
I mean,
no.
I mean X. I
Which
mean Y
equation?
equal X.
Y equal to X, so that means we should label on top here, maybe Y equal to X. Okay, then how about the lefter function? So it's on the right, so who's on the left in region A? This guy, right? Okay. So what is the equation of a vertical line like this? The y-axis. Something equals 0. Which one? Look at all the points along this y-axis. They all share the same what coordinate? This is 1, this is 2. Like let's say this is point 2. What's the coordinates of this point?
The coordinate sub.
It's on the y-axis itself. And it happens, let's say, for example, this is 2. What's the coordinates? X comma y.
Something then 2.
Y is something on the y-axis.
0, 2.
0, yes, because here you must remember that coordinates is really just an instruction for how a claw machine. Imagine you're in a bird's eye view and you are controlling the claw in a claw machine. The X here is asking the claw, how much do you want to travel to the left or to the right? In this case, 0, because you're starting from the origin, you don't move left, you don't move right, you stay along this line. Then positive 2 here is the y direction. It's telling the claw machine to travel positive 2 units upwards. Positive 2 units in the y direction. Positive meaning move up. So 1, 2. You don't move left and right. Does that make sense?
Yeah.
Okay, so 0, 2. How about this other point here when it's 3? What's the coordinates of this point? Again is not again, but what's the coordinates? A point on the y-axis that passes through this 3. 3.
3, 0.
3, 0. Oh no. No. Think about it in the claw machine, in terms of the claw machine. How do you travel from the origin towards that point? Do you need to move left? Do you need to move right? You start here. Do you need to move left? Then you travel towards that point?
0, 3.
0, 3. You don't need to move left and right. So the x coordinate is 0. Then the y coordinate is positive 3, so that you can start from the origin. Then you go up 3 levels. Positive 3. Okay. So, what do you notice? A pattern. Again, this is x. Again, that is y. What is the common pattern here? Which point is the same? And there's also 0, 4. What stays the same?
The x-axis.
The x coordinate is always equal to
0.
So the x always equal to 0. So what do you think is the equation of the y-axis now? The x is always equal to 0. So what do you think is the equation of the y-axis? X equals 0. Hello?
Yeah.
Test, am I connected? Okay. The x coordinate is always equal to 0 in all of these points that are on the y-axis. So what's a natural way to describe the y-axis? X equals 0 lah. Make sense?
Yeah.
Okay, very good. So we have x equal to 0. So over here, you write down x equals 0. Okay, maybe I'll format it nicely as x equals y. Okay, like this. Good. So go back to what was I trying to describe here? I was trying to tell you, okay, let me erase all this. You should know the equation of y-axis. Okay, neater. What was I saying? I was saying, look at region A. Who is the righter function? Who's the lefter function? Okay, we identify already. Right-er function is x equal to y. Left-er function is x equals 0. Make sense? Okay, I draw for you an alien. Okay, alien is over here. This is alien. Ah yeah, my alien is blocked. Alien point here, alien point there. Okay. Right function over at the top, left function at the bottom. This is region A. Is that okay? Very good. Let me just make it a bit more precise. I need to extend a bit and draw a few more horizontal lines. Then you can mimic this region A already. Okay, how about region B? Now tell me quickly, who is the right-er function? Who's the left-er function?
4y minus y squared is the right-er function.
Good.
Left function is just x equals 0.
Yeah, it's just x equals to 0. Very good. So now that you have this diagram, you can translate it into an integral. So here, it will simply be integrate x something minus x, the other thing, dy. But here, the x, the first one is the right-er function, which is y, and the second one, which is a 0. That's for the first region from y equals to what to what? What's the limit?
Oh, it's a 0 to 3.
0 to 3. Okay, very good. 0 to 3. Okay. That's the first region. Can you see? That's the first region here, separated by a what do you call it? Y equal to 3. Then another region here. So what do you need to do now to find the total area? This is only region A. You still need to plus?
Plus from 3 to 4.
Then minus 2. Okay, very good. Exactly. Okay. Okay, then just calculate. Y squared over 2 equals 0. 3 plus integrate this, get y squared over 2. So 2y squared minus y3 over 3. Y equals to 3, y equals to 4. Sorry, handwriting. Let me write it neatly. Can. Then sub in 3 squared over 2 minus 0 plus. This one is 2 times y squared minus y cubed over 3 minus, I'll replace with a 3. 2 times 3 squared minus 3 power 3 over 3. 3, 3, 3, 3. Okay, now over 2 plus this one. 4 squared, 16, 16 times 2, 18. Nope, 16 times 2, 32. 4 cubed, 4, 4, 16 times 4, 64 over 3 minus 3 squared is 9. This is 18. Oh, what's this again? 27 over 3 is 9, correct? 18 minus 9 is 9. Then you're left with minus 9. Right? Good. Okay. You know what, at this stage, I'll just use a calculator. Okay. Let's see what we get. So 9 over 2 plus bracket. I don't need that bracket actually. Minus 64 over 3 minus 9. And I get a 37 over 6. Okay. Very good. Okay, we are done with this question and this worksheet actually. I think so. Okay, so what do you learn today? You learn how to draw the right-er and left-er diagram. Or in the case where it's dx, then it's upper and lower. Okay, the trick is you must really go and find the point of intersection. Then you draw that either a horizontal line or vertical line. Typically, if it's with respect to x, you just draw a vertical line. If it's with respect to y, you draw a horizontal line to split the region up, the region they want you to find the area of, into smaller regions, like region A and region B. Okay, then you just need to identify who's the upper and lower function within one region that translates to the first integral. And then for the second integral, you have to do the same thing, find the lower and upper limit, and then figure out who's the upper and lower function. Then you substitute in accordingly. Upper function here, lower function there, minus in between, and integrate from that region, x equal to y equal to 3 to y equal to 4, that particular interval. Okay, good. Yeah, so why is this negative? Y minus 4y minus y squared. Just to answer our question, maybe it will be neater if I just copy this diagram and relabel all the pieces. I already use A and B. Maybe I'll just use C, D, E. Okay, let me get my eraser. Erase the regions. Okay, what is this? What were you doing here? Y minus 4y minus y squared.
Because y is on top. It's like
so let's just label some of the regions. Maybe I'll call this. Let me think a bit. Okay, C, E, E, and F. So if you integrate 0 to 4 of y minus that guy dy, I can split it up like this, right? Do you agree? I can split it like this. Right, because it's the same, split it with the same upper and lower limits. Okay, so what is the integral from 0 to 4 of y? It's really just, in terms of the letters, it's which regions? There's an invisible y minus 0. I guess, if you want to think of it as righter and lefter.
4.
So over here, actually, I need to draw one more horizontal line here. And then I call this region G. This area that you found here is actually E plus F plus G. Can you see that? The area under the straight line, which is this right angle triangle, right? That means definitely wrong already. There's an extra area G that's not required. Okay, then let's continue. Put a minus, maybe a pair of brackets. There's an invisible pair of brackets. Remember, after a minus sign, there is always an invisible pair of brackets like this. Okay, it's just that it's usually omitted to make it look nicer. Yeah, math notation avoids negative signs to make it look nicer, even though it's actually there. So how about this part? Integral of 4y minus y squared from 0 to 4. In terms of the letters, what area is it representing?
It's representing isn't it all?
Wait, sorry?
Isn't it all except for G?
So it's C, D, E, and F, right? Okay, so we write down C plus D plus E plus F. Then let's simplify it using a bit of Sec 1 algebra. Expand, multiply the minus sign in. What do we get? Let's see. E plus F plus G minus C minus D minus E minus F. Anything to cancel off?
No.
Huh?
I mean F and E.
F cancels away with F, E cancels away with E. So now you are left with G minus C minus D. Okay, so what is G minus C minus D? I have no idea. It just so happens that G is some very small area. D and C are some very big areas. Okay, you can interpret it like this. G minus away, factor out the negative, C plus D. So what you're essentially doing is you're taking the area of G minus away C plus D. Region G is a very, very small area here. C plus D is a very, very big area here. You take small minus big, what do you get? Negative. Does that answer your question? Why is it negative? Because you took a small region minus a big region. Of course, you get a negative. Okay, and it's G. So you end up with your answer ends up finding the how do I say this? It finds the area of this difference. It finds the area of G and the area of C plus D, and you take the difference between them, which is not answering the question. Yeah, the question is asking for F plus D. Yeah. This one definitely not F plus D. Okay. So this labeling trick is very, very useful. Okay, it will immediately tell you whether your answer makes sense. Is that okay? Can? Good. Okay. Moving on. This one was okay. Everything else was okay. Yeah, I never comment means it's okay. All right, moving on. So let's try some of the questions that were what was that? The Pulse Online Math Notes one, I will leave you to try as homework. Then this one, I'll go through some of the questions that were not assigned as homework. I asked you to do what worksheet is this? This is the what do you call this? Xingli workbook. Okay, so I'll do the questions that came before question 18. Because if you look at the homework for last week, I assigned question 18 onwards. Okay, I'll try some of the questions before that as a recap. Okay. Yeah, so let's see. I guess we can start. Okay, this one, which is interesting. Which one do you want me to try? Basic? Yeah, basic. What? This one. Okay, let's try this one. I think you are a bit confused by this kind of
I don't like
questions, whether fx is not given, right? Okay, let me start a new worksheet first. What's today's date? It's 1/7. Okay, paste. Let's see. So integral of 1 to 4 of f of x dx is equal to 9. Integral from 0 to 4 of f of x dx equals to 5. Here, always pretend that fx is like some squiggly line. I like to draw a sine curve. Okay, and it's floating in the middle of the air in like quadrant 1. Why quadrant 1? Because over here we got integral from 1 to 4, then 0 to 4. So, okay, since there's a 0 involved, I need to extend the curve a little bit. Can you interpret, what's this? 0 to 1 equals to 4. Is that right? Yes, correct. Very good. Here, the geometrical interpretation is like this. When you start from x equal to 0 to x equals to 4, you end up with an area that's equals to 5 unit square. Then from 1 to 4 means, maybe I'll use blue line, 1 here, x equal to 1, to x equals to 4. The region there is, let me see, what did they say? 9. Okay. Does that even make sense? That's a bit odd. Right. Okay, no, it's correct. I'm just confused because I never sketched it properly. Right, the red region is bigger than the blue region. You minus and you get the difference of 4. Is that right? Okay, this is not very logical because the red region is 5 units, the blue region is 9 units, even though the red region looks bigger than the blue region. But if you follow the rules, okay, I need to come up with a better sketch. But if you follow the rules, what's going on is integral from a to b of fx dx plus integral from b to c of fx dx it will just be equal to integral from a, skip the b, jump straight to c, fx dx. Okay. Very good. So over here, what you can do is integral from 0 to 4 fx dx. You introduce something in between, which is 1. So integral from 0 to 1 fx dx plus integral from 1 to 4 fx dx. Okay, then after that, you realize that, oh, 1 to 4, that's the answer, it's 9. 0 to 4, that's the answer, it's 5. So this is the only thing that's left, which is what's requested in part A. And from there, you can make the thing the subject. Integral from 0 to 1 of fx dx, which will be 5 minus 9, which is, oh, it's actually negative 4. Ah, wrong, your answer, positive 4, not correct. I guess that kind of makes sense. Yeah, if you take a look here, this red color region is positive 5. This blue color region here is positive 9. So 5 minus, big minus small, 5 minus 9, but you end up with 5 minus 9, which is negative 4. The diagram doesn't really make sense. But just remember this identity. Upper limit, lower limit, same. You can you can combine them together and just start from the lowest limit to the uppermost limit. A straight away to C. The picture to remember is just a curve like this. There's A, there's B, there's C, x equal A, x equal B, x equal C. Integrate A to B is the left area. Integrate B to C is the right area. How do you find the total area straight away? Just integrate from A, skip the B, jump straight to C. Does it make sense?
Yeah.
Right, because integral, definite integral is always an area under a curve, bounded between two vertical lines when you're integrating with respect to x. Okay, very good. Let's move on to part B. Part B, how? Okay, this diagram, let me just shrink it down, not so useful. Integral from 1 to 4 of root x minus fx dx.
Y equal root x.
Square bracket. Sorry? Something on the left, something on the right, minus in between.
Y equal root x.
Sorry, what is equal to root x?
Like the upper thing.
Oh, you want to interpret it geometrically? No. I don't think that will be useful. Because you see, this part here from 1 to 4 is already smaller. 0 to 4 ends up being bigger. 1 to 4 ends up being a bigger value of 9. 0 to 4 ends up being a smaller value of 5. So it means that it's a bit difficult to visualize. Better to do it analytically, use algebra. Remember, when there's a minus sign, what do you split?
Separate it.
And minus, what do you put for the limit?
Is 9.
Still the same.
1 to 4 fx dx.
Very good. Okay. 1 to 4 fx dx on its own already.
9.
Yeah, it's 9. Good. So minus 9. Then this part, can you integrate? Can. Power half, add 1, you get 3 over 2. Divide by 3 over 2. Okay. Square bracket. X equal to 4. X equals to 1. Okay, good. So 4 power 3 over 2 over 3 over 2 minus 1 power 3 over 2 over 3 over 2 minus 9. This over 2, this over 2 here means you take a square root. So square root of 4 is a 2. Then you raise to a power of 3, which is actually just 8 over 3 over 2. Minus 1 power anything is just 1 over 3 over 2. Minus 9. When you want to minus a fraction, make what the same? Make the denominator the same. They are already the same, even though it looks a bit funny, improper fraction. Never mind, it's just 8 minus 1, all divided by 3 over 2, minus 9. This gives you 7 over 3 over 2. Then you can multiply top and bottom by 2. 2 and 2 cancel away. You essentially bring the 2 up. Don't forget the minus 9. 7 times 2 is 14 over 3 minus 9. What's 14 over 3 minus 9? Let's calculate this. Okay, never mind. Just use the calculator. Minus 9, and you end up with a negative 13 over 3. Okay, very good. It will be a little bit challenging to visualize negative 13 over 3 because that will mean that you're taking a small area minus a big area. And the difference is negative. Yeah, that's a bit difficult to visualize. Okay. Not impossible, it's just troublesome. So just do it analytically. Okay. When you have a minus, just split into 2 pieces. Keep the same limits though. Don't be confused with this guy. The A to B and B to C, there are different limits. Whereas this part here, when you're splitting into 2 separate integrals, the limits are the same. Okay. Now next one, last one, integral from 0 to 4, 3 times f of x minus 2x dx. How?
Okay, split up.
Split. How? Equals?
15 minus.
This one is 3 times this guy. And then it's 3 times 5, which is 15. Okay. Then? Okay, good. Let's just calculate it. So factor out the 2 first. I will do that first. And then you integrate x. You get x squared over 2. 2 cancels away. Sub in x equal
6
to 4 and 0. You end up with a 4 squared minus 0 squared, which is 16 minus 0, which is 16. So minus 16, you get negative 1. Okay. Good. Let's try another question. Oh, wrong page. Let's see. Wow, this one. Question 5. Okay, not that simple. Okay, let's see. So you have an integral from 0 to 2 of fx dx equals to a. Integral of g of x from 0 to 2 is negative a. Okay, then where a is a positive constant. Now part 1, I express 0 to 2 of 2 times fx minus 3 times dx in terms of a. So first step, copy down what's given. And you copy down the question. 0 to 2, 2 times this guy, minus 3 times that guy, dx. Equals, what to split?
2, then 2, isn't it just 2a?
Okay, 2a, good, yes.
Minus 3 times minus a.
Exactly, correct, very good. It's just minus 3 times integral from 0 to 2 of gx dx, which is minus 3 times negative a. Okay, good. 2a minus minus becomes a plus 3a, which ends up being 5a. Okay, moving on, part 2. Find the exact value of a if integral from 2 to 0 fx dx equals to integral from 0 to 2 of e power negative 2x dx. Copy first. Oh no, how come the 0 on top?
It's just negative a,
right? Yes,
Wait.
correct. Just negative a. When you swap the limit around, you just have to times the negative 1. So a to b fx dx equals to negative 1 times of integral b to a fx dx. Okay, you swap the limits times introduce an extra negative. So you can think of it like this. You swap the limits over on the left-hand side. So 2 and 0 swap place. You introduce a minus sign. But this guy was already previously given to be positive a, right? So you end up with a negative times a. Okay, good. Yep,
Yeah.
it's just negative a. Equals to the integral of that guy. How do you integrate e again? My favorite one.
It's just the same.
It's just the same thing. Yes, very good. Don't need to do work. Very lazy. Yeah. But this one, unfortunately, there's a coefficient in front of x. Ayah, need more work. What do I need to do? Differentiate, you always chain rule, you have to times. Now you're integrating, you work backwards.
Divide
Opposite of
by
times
minus.
is divide by -2. Very good. Okay. You already know. I don't need to say anymore. Very, very good. Then just sub in. So e power -2 times 2 over -2 minus away e power -2 times 0 over -2. Here, power 0, is it just equals to 0?
Yeah. Wait.
Haha.
No. Wait.
-2 times 0 is
0. E power 0. Isn't that just 1?
it's 1, not yes. It's 1, not 0. Trick question. This is -4 over -2. Can? Minus, minus. This becomes a plus. So plus a half. Okay, good. Actually, not so good. Not so good. Perhaps it will be better because this is a fraction minus a fraction. Denominator is the same. Maybe it's better if I just combine into a single fraction first. E power -4 minus 1. Okay lah. Can lah. If not, if you don't like it, you can multiply -1 on both sides. You get +2 here. I mean, top and bottom multiply -1. Okay. If you're still not happy, I got this e power -4. Can you just bring it down? Can you just bring it down?
Yeah.
And then it's equals to 1 times 2, and then
No.
plus e power +4. Huh? No. Or times maybe the plus change to times. No.
Cannot.
Cannot. Cannot. Very good. So there is a problem. You cannot bring down. So what if we want to express it in terms of positive power? Here's how you can do it. Multiply both sides of this. I mean, the numerator and denominator by e power +4. But take note, when you have an entire expression that has 2 or more terms being multiplied by another thing, you need a pair of brackets around the expression that has 2 or more terms. Okay. You got 1, 2 terms, so you must put a pair of brackets around it. Then you distribute. What do you get? 1 times e power 4, e power 4. E power -4 times e power 4, e power 4. Same base, different power, multiply. Add the power. So what do you get? Negative times positive gives you negative first.
And then
E power
0.
Yes, very good. So it's -4 plus 4, which is power 0. But power 0 is equal to
1.
Very good. Yes. So e power 4 minus e power 0 over 2e power 4. Then that's just a 1. Okay? That's a 4. Yeah, that's how you change into positive power. Multiply top and bottom. A bit like rationalizing the denominator. Right? When you have, like, for example, 1 over square root 2. This is like 1 over 2 power half. The trick here is to multiply top and bottom by 2 power half. So that half plus half gives you a 1. Right? And you're left with 2 power half, which is really just square root 2 over 2. Right? Of course, the more direct way is actually just 1 over root 2 times top and bottom by root 2. Root 2 times root 2 is 2, 1 times root 2, just a root 2 at the top. But the trick over here, when you want to go from negative power into positive power, is you want to make sure the power becomes a 0. So you multiply by e power +4 instead at the top and bottom. As compared to rationalizing denominator, you multiply by 2 power +half, because you want the pattern half plus half equals to 1, so that you can get a power 1. Okay, can you remember this idea? How to sort of turn the negative power into positive power? It's quite important. It's quite important. You will see it again in the future if you study complex numbers. Not now. Don't worry.
Mm,
Okay, so we are not done yet because we're asking us to find the exact value of a. Previously it was negative a, now it's still need to times negative 1. So it becomes 1 minus e power 4 over 2e power 4. Okay.
Mm.
Very good. Okay, let's try another question. This is recap. Wow, partial fractions. Okay, let's go. Let's go. Partial fractions. So first step is the partial fraction step where you need to write it in that particular format. So before you continue, when you look at the fraction, what do you have to check first before you start multiplying?
Proper or improper fraction?
Very good. Okay, so is this proper or improper?
Improper.
No, proper.
Oh, proper.
How do you check?
Degree.
Degree.
The bottom is more.
Here is power 2. Highest power
Lowest
is
power.
2. So degree is 2. This one is x times x squared. So x power 3, degree is 3. 2 over 3, that is proper. What if it's equal power? Let's say I change this to power 3. Is it proper or
Then
improper?
long division.
Sorry, proper or improper?
Improper.
Improper. So the condition you must remember is degree of the numerator strictly less than degree of denominator. That is definition of proper fraction. Degree, DEG is my short form. Degree means highest power of x. Okay, in a polynomial. Actually, could it apply if it's fractional powers? I guess it can. Highest power, but not very ambiguous. Okay, anyways, if it's not improper, if it's proper, then we are good to go. Just copy down the expression they want us to give. But actually, even if they didn't give us this expression, we should be able to remember this identity. This is x squared plus 5. Is it factorizable?
No.
There's a plus sign? Cannot, because you only if it's a minus sign, then you can factorize. Okay, minus 5 can be rewritten as, if it was x squared minus 5, you can rewrite it as x squared minus root 5 squared, which becomes x minus root 5 times x plus root 5. Okay, that's provided if there's a minus sign. However, if it is a plus sign over here, confirm cannot factorize. What do we do with a non-factorizable, irreducible quadratic? You always come up with, you just copy down the denominator first, but the numerator, you must come up with something that is 1 degree lower, which is, in this case, power 1, x power 1, linear. Then you just have a coefficient here and a constant there. Okay. And this one, same thing. Dx minus 1 is a distinct linear factor. Linear meaning power 1. So you must go 1 degree lower, which is power 0. This is x power 0. Anything power 0 equals to 1. So it's essentially not there. Times 1. A is the same as a times 1, which is the same as a times x power 0. So 1 degree lower. Okay, so you should be able to remember this identity without the question helping you. Good, then now we cross multiply. So, oops, sorry, that's not power 3. That should have been a power 2. So you just leave the numerator alone, cross multiply that very huge denominator over to the other side. You end up with a times x squared plus 5 plus bx plus c bracket around both terms. Then multiply bracket 2x minus 1. Okay? Good, then you proceed. So now, let's see. I want to substitute x equals to a good number. Let's see. I could make 2x minus 1 equal to 0. Then that would mean x equal to half. But if x equal to half, there will be a lot of fractions, which will make my life very painful. I don't like to do that. So I'll just pick an easier number. Let's say x equals 0. Let's say x equals 0. So I end up with just a 15. Then this one is 0 squared plus 5, 5a. And 0 times b, what a coincidence, the b disappears. Very nice. Then left with just a c times 2 times 0 minus 1, negative 1. Very good. So we now have one equation in one unknown. No, that's not correct. It's one equation in two unknowns because there's a A and a C. Can we solve for A? Can we solve for C? Not yet.
No.
So we need another equation, right? That can help us. So how about we sub x equal to
Half.
half. Okay, no choice. I have to, cannot avoid already. So let's just do it. 7 times half power 2 minus 2 times half. It's 0.5 plus 15 is 63 over 4 equals to this one, half square plus 5. You get 21 over 4 times A. Continue, plus half B. Okay, half B like this, plus C, bracket, times 2 times half minus 1. Oh, right.
Zero.
This is 0. So you actually didn't have to sub in here. If you know it's a 0 straight away, 0 times anything just becomes a 0.
Can solve for A, then sub into 15 equal 5A minus C.
Yeah, let's think about it. So in this case, over 4, so we can solve times 4 on both sides, cancel away. A equals to 3. 3 times 21 gives you 63. Okay, good. So you sub in back into, let's call this equation 1. This gives me 15 equals to 5 times 3 minus C, implying C equals to 0. Okay, good. So we are not done yet. Now that we know 3A is 3, C is 0, let's just do a shortcut. 3 here, 0 here, can find B. So just to make it neat and tidy for presentation, I'll just clean it up like this. How do we find B now with the updated equation?
Can compare coefficient.
Oh, compare coefficient. Can, let's do it. So
x squared plus 3 plus 2b equals to 7.
So that just means 7 equals to 3 plus 2b.
Equals to 2.
Yeah. You can say CF, coef of x squared. Huh? What's CF? Confer. It's Latin for confer. It's just a very lazy way of saying comparing. CF. Compare the coefficients of x squared. Okay, coef is a short form. And then from there, 2b equals to 7 minus 3, 4. So b equals to divided by 2. 4 divided by 2, which is 2. Very good. We found our b equals to 2 already. Then we can replace the b over there with a 2. Then just replace accordingly. So this is 3, 2, 0. Okay, good. Then now, next part, what did they ask you? Hence, evaluate the integral of this same fraction. Integrate from 1 to 3. So how? Clearly, you must make use of the result here, right?
Yeah.
So that means that this integral, I'm lazy, I don't copy it. I hope you understand what I'm saying.
Yeah.
This equals to integral from 1 to 3 of that entire fraction. Okay? Dx. Let's just clean up a little bit. This is 3, that's a 2, that's no more already because it's a 0. Why did they want to do partial fractions? It's so that this integral can actually be done. Let's see. How do we integrate? Integrate term by term. Integrate 3 over 2x minus 1. What do you get? Factor out the 3 first. Then you integrate the 1 over 2x minus 1. Right? So what's the integral of 1 over x?
It is.
Just now we dealt with e power x already. What's a close friend of e power x?
Divide 2x squared minus 1.
Oh, no. 1 over linear. 1 over x.
Oh, lol. Wait, what?
Exactly, but the x, 1 over x is now 2x minus 1. So that means you end up with, integral 1 over x dx is ln of x modulus. But the capital X now it's 2x minus 1. So what else do you need to do when you have a coefficient of 2?
Ln x divided by 2.
Yeah, you have to take ln modulus of the entire expression. But you have to divide by 2, which is a half in front. Can you remember this?
Yeah.
Yes, because chain rule, right? Ln will give you 1 over this guy. But chain rule tells you there's a 2x minus 1, you still need to times 2. The times 2 and the half in front will cancel away. And then you're left with the 3 over 2x minus 1. Just factor out the 3 first. Okay, moving on. Plus, try this other one. Okay, this one, okay, sorry. You need me, this one, you will need to do a clever observation here. Can you see that, if I take ln modulus of x squared plus 5, I'll get the answer. Can you see why?
Why?
No. How do you check whether your integration is correct?
Differentiate ln
Yes.
modulus. But then
just ignore the modulus sign first. Pretend that they are round brackets.
1 over x squared plus 5.
And then chain rule.
Or then 2 times 2.
Know what's inside the brackets of the ln something, in this case the something being x squared plus 5.
X squared plus 5.
Yeah. Y equals ln of x squared plus 5, right? What's dy by dx?
1 over x squared plus 5 times
derivative of the inner function, which is x squared plus 5. Chain rule tells you to
2x.
d inner, right? Which is 2x. Oh, then 2x, you can write it on the numerator. 2x over x squared plus 5. Wow, amazing. That's the same as this guy. So that means integration is the reverse of differentiation. So you can go backwards. This one was going forwards. Now we work backwards. Okay, working backwards gives me ln of that guy. But just remember a rule, you must always put a modulus. Yeah, always put a modulus to make sure the logarithm is defined. Now, if it's negative, then it won't work. In this special case, x squared is always more than or equal to 0. You plus 5 to it, so it's more than or equal to 5, which means it's strictly bigger than 0. X squared plus 5 is strictly bigger than 0. Is it clear? Right? If it's strictly bigger than 0, then it means you don't even need the modulus sign anymore. Just round brackets will do. Just round brackets will do. Because x squared plus 5 more than or equal to 0 plus 5, which is clearly strictly bigger than 0. Right? 5 is bigger than 0. So that means you don't need to put modulus anymore. Okay, this is actually something known as the reverse chain rule. Right, you've seen it before as a part 1 and part 2 question, right? Right, part 1, you differentiate, you get this form, then try to integrate this guy. Later I can try another question. You'll see that question and remember already. But anyways, just to quickly finish up, we end up with 3 times ln of whatever plus ln of whatever. Okay, you know what? Let me just keep on the modular sign. Keep the modular sign. It's not wrong to do so. Here, can you see that I can combine into a single fraction like the following? Can you see how I can combine into just this single expression?
Yeah.
Can, right? Because at this power rule for logarithm tells you can bring the power up. And addition means it becomes a multiplication. Then I'll just put a modular sign around the whole thing. But take note, actually I missed out a step, which is this is integral from 1 to 3 dx. So I actually need a square bracket. X equals 1, x equals 3. Almost forgot about it. So just fill in the blanks. X equals 1, x equals 3, x equals 1, x equals 3. And then you substitute in. This one, they're asking you for decimal approximation. So I'll just leave you to type in the calculator on your own. Okay? 3dp. Good. Okay, let me try one last question. Maybe is question 7 worth doing? No. I want to try a area question. So let's see. Which is good. I think these are all pretty okay questions. This one. Okay. Let's try this one. Question 25, part 1 and part 2. Okay, let's take a look at this one. So we start off with the concept I was telling you just now. Differentiate first, and then after that you find the integral. You remember this kind of question? So differentiate 3x squared ln x. What do you get? Keep one, differentiate the other, plus. Carry on.
Plus ln x. Then differentiate 3x squared.
Factor out the 3 first. Then you differentiate the x squared itself, which is 2x. Okay? Okay. Good. So 3 times 2 is 6. You get 6x ln x. Plus in between, 3x squared over x is 3x. Okay? Good.
Yeah.
Then now let's take a look at part 2, what they say. The diagram, it shows part of the curve y equals to x ln x for 0.5 less than equal x less than equal to 2. They drew this using graphical software. Right? Good. Using your result in part 1, find the total area of the shaded region.
Same function, but we have factor of 3x.
Yeah, so maybe it's nicer if I write it as one single line like this. Derivative equals to answer. Then what can you do? Let me just make a very clever move first. Swap them around first, and then I put on the opposite of derivative is integral. So integrate dx, integrate dx. I need a bit more space on the left side. Okay, so what happens when you integrate a derivative? Just remember they will cancel each other off. Okay, then you're left with 3x squared ln x. Okay, good.
Yeah.
But you probably need a plus c, but never mind. We will omit the plus c until the last step. You should have a plus c here because it's a indefinite interval. But it's okay, don't need. Over here, the emphasis, left side, when you have a plus sign in between, what do you want to do?
Plus sign in between can split.
Yeah, so integrate the first guy 3x dx plus integrate the second guy 6x ln x dx. Okay?
Yep.
Good. What's integral of 3x? Take down the 3 first. Integrate x. What is it?
Integrate x is just. Is it ln? Wait, what? Wait.
No. Integrate 1 over x dx is on x. Modulus. This is just normal integration. X power 1.
Yeah, minus 1, and then, but it's x power 0.
No, minus 1 is differentiation. Oh no.
X squared over 2.
Yes, add 1, get the new power, divide by the new power. Integral x power n dx equals to x power, add 1 to get the new power n plus 1, divide by the new power n plus 1. Wow, forgot already. Oh no, no. Plus C. Can always factor out the coefficient 3 first. Then you just have a coefficient 1. Then you can just use this formula. Add 1, get the new power, divide by the new power. Add 1, get the new power, divide by the new power. Add 1, get the new power, divide by the new power. Okay, remember already. Very good. Then plus, this guy cannot do anything, so we factor out the 6 first. Okay, then 3x squared ln x also cannot do anything. At this stage, I still don't put a plus c. Still don't put a plus c. Later, very last step, then put a plus c. Okay, then over here, you realize that this is actually 3 over 2x squared, so you can bring it over. So you end up with 3x squared ln x minus 3 over 2x squared. And then this is 6 times of that integral. But remember, this function that we are dealing with in part 2 itself is x ln x, right? So that means that we probably need to integrate x ln x from here to there, and there to there. Okay, so that means we need to figure out what's integral x ln x first. So we can divide by 6, exactly. So 1 over 6 times of all of that. Right, divide by 6 is the same as times 1 over 6. Then at this stage, I put plus c. Okay, distribute 3 over 6 is half, so x squared over 2. Okay, maybe it's nicer if I write it as half x squared ln x. And then minus 1 over 6 times 3 over 2, 3, 6 cancel away, left with 1 over 4. X squared and then plus c. Okay? Very good. Just to make it a bit nicer, I will copy this x ln x integral down. Okay, now let's read the question. What do we want to find? Let me just define this guy as little f of x, okay? X ln x is f of x. F of x. How do you find the area here?
You use
integrate.
Different wait, what? Integrate the x ln x.
Yes, which is in this case f of x. Because I'm lazy, I don't want to write so much. So f x. From where to where?
1 to 2 plus.
Okay, that's a region A. Okay.
Plus
it's a region
from
B.
0.5 to 1, but it needs to be modulus.
Very good. Yes, you remember. I was waiting for you to make a mistake. Yes, because it's negative, because it's below the x-axis, it will be negative. But we want area, so it must be positive. That's why you must put modulus here. Okay, good. Okay, and you must remember that if this value inside is negative, modulus will make it positive, which essentially means you're multiplying by -1 to it. Right, so that means that you can actually simplify this a bit more. No space. Simplify a bit more by changing the modulus here into bracket times -1. Okay, we already know that it will be below the curve from 0.5 to 1, so it must be negative. But we want positive area, so just times a -1. Okay? Okay, very good. So now with this expression, we can carry on and find the area. So this, because I already wrote it as f of x, right? This itself is integral fx dx. Okay, good. So let's just recycle our working. Area equals integral from 1 to 2 of fx dx. So this guy, integrate already, will just give me that guy, correct? We need the plus c?
No.
Don't need. Why?
Because it will cancel itself out.
Yeah, when you substitute x equal to 2 and x equal to 1 in the definite integral, sorry, the plus c will stay the same. It will cancel each other off. So anyways, we can just copy down this whole thing without the plus c, then just label x equal to 1, x equal to 2, lower and upper limit respectively, plus -1 times integral from 0.5 to +1 of the x ln x, which will give us this as the answer, the indefinite integral, but drop the plus c, then you sub in x equals to 0.5 and 1. Why is it -1 times again? Again, it's because the region B is below the x-axis. It will be negative. But the question asks for area. Area is positive. So that's why over here, need to times a -1 to make it positive. Okay? Modulus is equivalent to multiplying -1 if you already know that the inside must be negative. Can?
Yeah.
Very good. But just take note, it's not always modulus change into -1. Because if it's already a positive number, it stays the same. If it's a negative number like -4, then it becomes -4, whatever was inside, times a -1. So you need to know for sure that what's in between the modulus is a number that has a negative sign already, then you can times -1. Otherwise, you leave it alone. Otherwise means it's positive or 0. You leave it alone. Okay?
Yeah.
Okay, I better write down the reason. Because I know this guy is negative. How do I know that? Why? Because region B entirely below x-axis. Entirely. If it's halfway in between, maybe a bit more confusing. Anyways, moving on. So now we just sub in. So you know what? Let me just be a bit more lazy with the notation, with the substitution. Because wow, I have to sub in the x here, so tiring. There are 3 positions to sub in with x equal to 2, and another 3 positions to sub in with x equal to 1, and another 3 with x equal to 1, and another 3 with x equal to 0.5. So tiring, right? So let's try the lazier notation, which is after you, after you obtain this expression, let's just call this a capital F of x. Okay? You know how integration gives you the area under a curve, right?
Mm-hmm.
So here, essentially what you're doing is you're taking many small rectangular strips. If you remember that lesson when I mentioned this, I showed you the decimals, all these rectangular strips. What you're essentially doing is you're taking all the small little rectangular strips and adding it up to get a big shape, right?
Mm-hmm.
So that's why this notation makes sense. You integrate means you add up a bunch of little small things, which is the lowercase f. You eventually get a very big thing, which is a capital F. Capital F is bigger than little f, right? Uppercase.
Mm-hmm.
So that's why this notation, you can sort of intuitively understand it if you remember the idea of building up to the total area by starting off with individual tiny strips of rectangles, right? And you add all the tiny strips together to give you the big area. So integrate a little f. In the end, you'll get a capital F. Anyways, this is the capital F notation, f of x, representing this expression, so that I can be lazy and not write so many things. In other words, our integral of 1 to 2 of f of x dx becomes capital F of x. Then you put square bracket, x equal 1, x equal 2. Wow, you see, so much neater, right? Don't need to write so many things. Can understand what I'm saying?
Yeah.
And -1 times off, same thing over here, just becomes a capital F, square bracket, x equals 0.5, x equals 1. Okay, good. Then now we sub in. Don't need to sub until you sub until the cows come home. You also haven't finished. What cow? Why got cow come home? I don't know. Sub in x equal to 2, x equal to 1 just one time. Don't need to do so much work. Then plus a -1 times off. Same thing here. f1 minus f0.5. Okay?
Mm-hmm.
Very good. Then now you proceed to multiply -1 inside. Let me just bring the working down. Okay, so f2 cannot change, f1 also cannot change, plus -1 times of that guy. So becomes a negative f1, and negative times negative gives you positive f0.5. Is that okay?
Yeah.
Very good. Hey, you notice something special here. Minus
Cancel.
f1? No.
I mean, 2.
-2 times f1.
Mm-hmm.
Okay. Then there's a f of 2 plus f of 0.5. I hope you're not confused by this F notation. Are you okay with it so far?
Yeah.
Can, right? Just think of them like an apple. F1 is an apple. F0.5 is a durian or rambutan. And F2 is a starfruit. Substitute different values of X, you get different values of the F of X. So they will be different. But in this case, apple with apple, -1 apple, -1 apple gives you -2 apples. So that's why there's a -2 there. Anyways, now you just have to substitute the values of 2, the 1, and the 0.5. You can just ignore this. All you need is the original expression without the C. Then you substitute in this case, X equals to 2. And then copy and paste this. You get -2 times our other guy, but substitute the 2 with in this case, it's 1. Do you get what I'm doing right now?
Mm-hmm.
And then plus, finally, F of 0.5. Replace all the places that had a positive red color +2 with what? With what?
Half.
Yeah, 0.5. Okay, makes sense or not? Everywhere there was an X, it becomes the 0.5. This was this. That was that. That one is that one. But the X becomes replaced with a 0.5 because here is capital F of 0.5. Okay, ignore the C because the C will cancel away when you have substitute. When the C already cancel away at this stage. Anyways, 0.5, 0.5, 0.5. What was the question again? Find the total area. They didn't request for exact. So I guess you could just type this in the calculator to help you get the answer. Or you could do it or you could leave it in terms of ln 2. Yes, you can leave it in terms of ln 2. Okay, let me show you the exact expression. It's just playing with logarithm identities now. Okay, toss this aside. This you can rewrite as half times 2 squared is 4 times ln 2. Minus 1/4 times 2 squared. 2 squared is 4. 1/4 times 4, that becomes a 1, -1. Minus 2 times, don't just cancel away with the half because there's actually a pair of square brackets here. Must multiply into both. So for the first one, 2 times the half will give you the 1. So that means -1 times 1 square, which is just 1, times a ln 1. What's ln 1 again? Look at the graph of ln graph. Look at the ln x graph. When x equals to 1 is 0. So that means that this guy here is actually 0. This whole thing is -0. -1/4 times 1 square. I made a mistake. What's a mistake?
What's the mistake? What's the mistake? The -2 never go into the second term.
Yes, correct. So that means you should actually have a, okay, let me see. Minus becomes a plus, and then you have an extra 2 here. Okay, this simplifies into just 1/2. Okay, moving on. Next plus. This one half times 0.5 square. 0.5 square means half square, which is 1/4. So half, okay. So half times 0.5 square is actually half times 1/4, which is 1/8. Good. 1/8 times ln of 0.5. Okay, so ln of 0.5, this one a bit special because you can rewrite it as ln of 1/2 3. Yes? No? Okay. Then there's a special trick you can do. Hey, how about we rewrite this as 2 power negative 1? Can? Yes, then negative 1, you can bring it down. Negative ln 2. So now it's in terms of ln 2, which is very good. Now we can replace ln 0.5 with negative ln 2. Close the bracket. Don't forget minus 1/4 0.5 square. This one is, what was it again? Okay, we don't have a calculation. 1/4 times 0.5 square. Half square is 1/4. 1/4 becomes 1/16. So minus 1/16. Okay? Very good. Now we can simplify everything. So 4 and 2 cancels off to give you 2. So this is 2 ln 2 minus 1. Minus 0 can ignore. Plus half cannot ignore. Plus, this is 1/8 times negative ln 2. So minus 1/8 ln 2. This is minus 1/16. I can't do anything about it. Okay, good. Now combine like terms. Treat ln 2 as an exact value. So 2 ln 2 minus 1/8 ln 2. 2 minus 1/8 is, let's see, 16/8 minus 1/8, 15/8 ln 2. Okay, then after that, you got minus 1 plus half minus 1/16. Minus 1 plus half is minus half minus 1/16. This one can times 8 times 8. It means minus 8 minus 1/16, which is minus 9/16. And that's the exact answer. Okay? Okay, good. So that's it for today. The rest, I will assign the homework later.
Okay.
Any questions? Okay.
No.
Yep, that's it. So the area, this 15/8 ln 2 minus 9/16 is the area of this region. Okay, that's it.
Oh my gosh.
Yeah.
Why is math so hard?
Yeah, just practice. Okay,
Math so hard.
thank you. Bye-bye. Any questions? No questions?
No.
That'll be all for today.
Okay.